One more example. Find the average speed if you go to a place at 50 km per hour and return at 75 km per hour. We are talking about a to and fro journey between the same 2 points, one way at 50, the return at 75. Now there are multiple approaches to doing this, but let's start from the fundamentals. We don't know the distance, right? So we can assume the distance to be d, one way. Let one way distance be d. So that means the first part, the time taken to go forward would be d by 50, and the time taken to return would be d by 75. So the total time is d by 50 plus d by 75, which you will simplify by using 150 as a common denominator, 3d plus 2d, which is 5d by 150, which is d by 30. Now the total distance was d one way and d the other way, 2d. So the average speed would be 2d divided by d by 30. Notice that the d cancels. The answer is not dependent on the distance itself. 2 divided by 1 by 30 is equal to 60 kilometers per hour. That would be how you solve this question from the fundamentals. Minor optimization, when we do this is when you're solving this rigorously for your school exams, for example. In a competitive exam, you will not bother with this variable. You would know that it is invariant at the distance, otherwise it cannot be determined. It is always faster to just take the LCM of the given speeds. So I might say let the distance be 150, and that makes for easier calculations in the subsequent steps. That's one thing you can do here. Also, you can try doing this with you know, arbitrary constants. My forward journey was a kilometer per hour and my return journey was b kilometer per hour. And that will actually get you to a nice little formula. Let's look at that. So we have a certain distance. This way I'm going at a kilometer per hour. This way I'm going at b kilometer per hour. And as I said, instead of just taking a distance d, you could take the LCM, in which case it would be AB. It doesn't matter, you can do it both ways. Let the distance be d. So the total distance would be d plus d, which is 2d, and the total time would be d by a forward journey and d by b return journey. This will become b plus a. It's basically AB in the denominator and BD plus AD. Now all you need to do is divide these two things and you will see that the D's will cancel and the AB, which is in the denominator of the denominator, goes up to the numerator and you will have A plus B below. So this is a direct formula for average speed for a to and fro journey. If the forward journey is a kilometer per hour and the return journey is at b kilometer per hour, the average speed for the whole journey is 2ab by a plus b. Nice little formula to have, but don't forget that we are just deriving it from a general case. That is all it is. The fundamentals are important as well. We will use this formula a little later. A third thing that you want to consider is, hey, if you go back to the original question, the question said 50 one way and 75 the other way, right? Can I just say that the speeds are in the ratio of 50 to 75 and the distances are basically in the ratio 1:1, right? Can I just put that on the number line and then find the point that divides in that ratio? Just flip that ratio, it is again 1:1. Can I just use this to find the average speed? The answer is no, not directly. You cannot put the speed ratio on the number line, speeds on the number line, and the distance ratio as the weight ratio. You cannot do it. You have to put time ratio here. That would work. The distance ratio would not work. So if you want to use a number line, what I suggest would be this. The time ratio can be found as the uh, ratio of the distance ratio and the speed ratio. Because time is distance by speed, time ratio is obviously distance ratio by speed ratio, and the distance ratio is basically 1:1, which I'll write as 1 by 1. And the speed ratio, I'm going 50 one way and 75 return, so that's basically 50 by 75. This turns out to be 3:2. Now that you have the time ratio, if you want to put that on a number line, you can. My speeds are 50 and 75, and my time ratio is 3:2. This would be appropriate. This would give you the right answer. You flip it and you get 2:3, and if you divide the distance between 50 and 75 in the ratio 2:3, you would get 60, which, as we already know, is what you're supposed to get. And so this is right and this is wrong. If you have the speed ratio as the two endpoints on your number line, you cannot put the distance ratio as the weight ratio. You can put the time ratio. There are multiple ways of doing this. As you have just seen, you've seen the fundamentals, you have seen the formula, and you've also seen how you can do it using the number line. Let's look at one more question. One day, a man went to office at p km per hour and returned at q kilometers per hour. The next day, he went at 3p km per hour and returned at the same speed as before. That's q. And he saw that his average speed had increased by 80%. So basically, his average speed for the to and fro journey on the second day was 80% higher than that on the first day. Find PQ is the question. Now here it would make sense to use that formula we just derived. So the average speed for the to and fro journey on the first day was 2pq by p plus q. The average speed on the second day would be 2 into 3p into q by 3p plus q. And it says that the second one is 80% more than the first one. So it is into 1.8, but I'm going to write it as into 9 by 5. Get rid of the decimals. See what you can cut first. 2 and 2 is gone. PQ is gone. I'm going to cut 9 with this 3 and you'll have a 3 left. Now you can cross multiply. You have 9p plus 3q on the LHS, and you have 5p plus 5q on the RHS. That is 4p is equal to 2q. P by q is equal to 1 by 2. And that's your required answer.